Looks like we're live. Hello everyone and welcome to yet another recreation programming session. How about that? I bet you didn't expect that. So let's make a little bit of an announcement and officially start the stream. Right, so we're gonna do usual red circle live on Twitch. And what are we doing today on Twitch television website? Today we are doing a small AI image model in C. How about that? I'm gonna give the link to twitch.tv/studying, the place where we're doing all of that, and I'm gonna ping everyone who's interested in being pinged. There we go, the stream has officially started. So today we continue developing our deep learning framework in PRC that we started to develop like a couple of streams ago. You can find the link to this framework in here if you're interested. I copy pasted it in the chat. And for people who's watching on YouTube, it's gonna be in the description. So what we did on the previous stream, we implemented a very interesting, well, it's not that interesting, I'm pretty sure a lot of people before me done that before, but basically a compression algorithm for images. So what we did, we created a neural network that behaves like a certain image, right? So essentially we got the image from the NIST database. Let's actually go here. So here's the NIST database and training, and let's actually take the digit 8. Right, so this is gonna be black. And I'll go here is the image. So we started with like a very small images, and we're trying to train a neural network that behaves like that specific image, right? So let's actually start that specific application that will perform the training. So it's called image to NN. Right, so I'm going to provide NIST training 8, and I'm going to provide the image. So, and it started the UI where we can do the training. So essentially this is the target image. This is the neural network, the architecture of the neural network that we're using to imitate the image. And the way we imitate the image is basically we have 2 inputs and 1 output, right? So, and essentially inputs are the coordinates of the pixels, and the output is the brightness of the pixel. And we're using this image as the training set to train this neural network to behave like that specific image. Right, so here on the top we have the actual output, the current output of the neural network, its current behavior. So it's randomized, as you can see. It doesn't really produce any interesting result. It's just like a white noise, right? So nothing particularly special. So, but look what happens when we start actually training it, right? So it looks like the cost function doesn't do anything, it's just flattened out, but eventually it starts to go down, and it starts to learn the shape of the image. Like it roughly learns the shape of the image, and the more it learns, the more it figures out different features of the image. Right, so essentially at some point it will try to figure out the holes, right? So as you can see, it starts to like place a hole somewhere here. We just need to give it a little bit more time. Right, and at some point, eventually, if we have enough copium, it will learn how to behave like 8. Right, as you can see, it's actually figured out that you need to start like putting a hole in here. Right, and it's slowly putting a hole, and it actually climbs down. Sometimes it just starts to like wiggle around because it's kind of like a very difficult thing to figure out. But eventually, it will behave like an image 8. Right, and essentially, if the amount of memory taken by the weights and biases is smaller than the amount of bytes taken by the raster image, effectively what you did, you compressed, the digit 8. Right, you effectively compressed this entire thing. And the coordinates that we put into the inputs are actually normalized. These are the inputs from 0 to 1. So that means you can remap them to any coordinate systems you want, and you can even upscale, right? Because the neural network is a basically interpolator of a particular function. You can upscale it and make this entire image sort of smooth. And this is what our application does when we actually close it. It creates an image called upscale PNG, and we can take a look at how it looks like. So this is basically an upscaled version of this neural network that behaves like this image, right? It's kind of an interesting thing to experiment with, right? So I don't think there is any particular like a practical application to this entire stuff, but it's kind of interesting to just play with, right? Just make a neural network that behaves like an image, right? So that's actually kind of cool. So, and I was actually thinking, like, can we make it behave like two images? And how would you even encode that? Like, what does it mean for a neural network to behave like two images? How can you even do that? So, and I think the answer is rather straightforward, right? So let's actually restart the entire application. As you can see, we have two inputs in here, right? So it's X and Y. What if we go ahead and introduce another input into the mix, right? So what if we introduce another input? I wonder if I can, in this specific case, just go ahead and update the architecture. So let me find image2nn.c. Right, so where is the architecture? The architecture is located somewhere here. So what if we have three inputs in here? So let me actually try to rebuild this entire thing. So this is going to be ready environment build. So I probably have to put add in here. Right, there we go. So it's going to rebuild everything. This is going to take some time because we're streaming, so a lot of resources of my 10 years old laptop are consumed by actually encoding this stuff. And let's actually restart. So you can't do that. You can't easily do that because this entire thing sort of assumes a certain amount of inputs. But I wonder if we can basically say something like, okay, so here's the original thing. We're going to say that we have 4 columns in here, and in terms of amount of inputs and outputs, we're going to have something like this. I wonder if it's going to just work, right? If we just allow this entire thing to slide off like so, right? Hopefully it will work. So let me see. I think it should work. Yeah, there we go. So instead of 2 inputs now, we have the third one. Right, so, and as usual, the first 2 are X and Y, the coordinates of the pixel. But what's going to be the third one? The third one is going to be basically an index of an image. So essentially, we're going to train it to behave like one image when this neuron is 0, right? When this neuron is 0, it's going to behave like 8. Right, when this neuron is 1, we're going to learn it to behave like a different image. So that way we can basically flip-flop between the images, right? So on 0 it's one image, and on 1 it's a different image. But here is the catch. All of the inputs in this goddamn neural network are continuous. What if we train this mother flipper to behave like one image on 0 and like another image on 1, and then we're gonna try to render it with this thing set to half? What is it going to do? Is it gonna render something in between them? Like, I don't fucking know. Like I genuinely don't have any idea what it is going to do. Right, so we can just train it on 2 images, and can we just like render something in between? Will it render something in between? Is there something there? I don't know. I think that's actually kind of cool. Right, and what effectively it creates, I suppose it creates like a simple image model. Right, very simple image model with just 2 images, and you can basically slide one parameter around, saying that this image should be more like the first one or more like the second one. Right, so it would be kind of cool to also, in terms of UI, to implement like a scroll where you could just like scroll left and right and switch between these 2 images and see how it behaves. That would have been cool, I think. Right, that would have been cool. So let's actually try to implement this entire thing. So unfortunately, we're starting to get a lot of like training data. Well, a lot of, I mean, I have a 10 years old laptop. I'm sorry, I don't have $1 billion from Microsoft and Azure services and shit like that. I'm sorry. I was born in a third world country with just like a shitty laptop and stuff like that. Right, so I don't have a lot of resources. So we're starting to have a lot of training data, right? So essentially here we have 28 by 28 pixel image. So, and what that means, right? So if we do something like 28 by 28, so this is basically how many training samples we have, right? So it's almost 800 training samples. And if we are gonna have like the second image, we're gonna have basically over 1,000, right? And here is the interesting thing. So the cost function, the computation of the cost function requires you to have all of these samples. It requires you to iterate through all of these samples. So essentially the more data you have, the longer it takes to just compute the cost function, right? So, and eventually, what if we're gonna train on several images, right? So maybe on 10 images, right? So essentially, this is basically how many training samples we're going to have. Right, and it's already kind of slow with just 800 samples. It is already kind of slow. We can actually test it out. Let me show you. So especially when I'm streaming. So when I'm streaming, it's like all of that is extra slow. It is kind of sluggish, to be fair, not gonna lie. Oh, okay, so I do need to actually, you know, rebuild everything because I've made these changes. So let me actually quickly rebuild this entire stuff. So maybe I should disable building some things that are not related to what I'm doing right now, like compiling the adder and the gem and Zor and stuff like that. Okay, I'm gonna disable that. So it's already a little bit sluggish. So you can kind of see every time you restart, it's just like steps a little bit. So it's not really super smooth. It's not as smooth as if you, for example, were trying to train a Zor model, right? So in Zor model, you literally have like 4 samples, and this is how quickly it just like learns. Like it's just like, yeah, it's done learning, right? So sometimes it gets stuck in the middle, like here. Like I don't know why exactly it gets stuck, and especially this specific value gets stuck. Right, but quite often it just like it actually learns properly. So here it's very smooth, it's very fast, but when it comes to image to neural network, it's very slow because we have too many samples. Right, and the more samples we have, the worse the situation is going to become. So how can we overcome this kind of stuff? We can overcome that by introducing something that is called stochastic gradient descent. So currently we're using just the gradient descent, but we can introduce a stochastic gradient descent. So what is a stochastic gradient descent? So let's actually take a look. At least I'm going to explain how I understand what is stochastic gradient descent. This is how I understood it by watching 3 Blue and Brown videos. Right, so essentially you have your training set, right? So you have your training set. And it consists of samples, and it's a lot of samples. It's so many samples you don't really want to compute a cost function or backprop on all of the samples. Is just like gonna take too much time. Essentially what you do, you split your entire data into small batches, like in this case, let's say batches of 3, right? So batches of 3, and then you shuffle those batches around randomly, right? So you just shuffle them around, and essentially on each iteration, instead of training on the whole data set, you're training on one single batch, and then on the next batch, and then on the next batch, on the next batch, and so on and so forth. Right, so essentially if you had some sort of like a gradient descent, right, so essentially here is like your cost function, right, so there's a local optima somewhere here. In case of like the actual gradient descent, you would smoothly actually descend into the local minimum. But if you actually step with one single batch, right, one single batch, you're gonna go off somewhere. Just a second. You will go somewhere, but then if you go and step with a different batch, you will go somewhere here, and you will be going around like in like random directions all the time. But here's the interesting thing: since you go through all of the batches, in theory, on average, you're gonna converge still to a local minimum. Instead of going straight into the local minimum, you're gonna be just like waving around and just like going some places. But on average, you're gonna kind of converge there, right? But it's actually less computation intensive, right? Because you don't have to compute on all of the data. Right, does it make sense? So that's basically the idea of the stochastic gradient descent as I understand it. I might be a little bit wrong, but this is something that we can try to employ to combat the, you know, degraded performance, right? Because we're gonna have more and more data, and I have 10 years old laptop, so we have to do something about that. At least we should try. So, and this is something that we're gonna try to do first, right? So this is something that we're going to try to do first. And that's basically plan for today. Stochastic gradient descent, try to train on 2 images and like just see how they interpolate between each other, if they interpolate at all. Right. So, okay, so I see we've got some subs. Let me quickly acknowledge them. I think we got some subs off screen, specifically Twisty and Loguerto. I hope I pronounced your nickname correctly. Guy Wold, thank you so much for a tier 1 subscription. Nico Red H, thank you so much for Twitch Prime with the message. Yay! Yay indeed. LL Zor, thank you so much for Twitch Prime, really appreciate it. Ranzel117, thank you so much for tier 1 subscription with the message. Hello! Hello, my comrade. Welcome. Welcome to our epic deep learning club. It's so fucking deep, actually. So Dalimon, thank you so much for tier 1 subscription. Kachops, thank you so much for Twitch Prime. And Luxian Will, thank you so much for Twitch Prime. I don't know why UI keeps jumping around. But I guess this is just basically the web in 2023. Thank you so much, everyone, for subscribing. Let's go ahead and try to implement the stochastic gradient descent. So how are we going to be doing that? Right, it's actually kind of interesting. So we are doing backprop in here, right? So essentially we're doing backprop in here, and backprop already kind of accepts the input data and expected output data, right? So essentially, if you think about it, if we take the sub-matrices of Ti and To and feed it into the backprop, it will already kind of work. Right? It will already kind of work. So essentially what we need some mechanisms, some functions that allow us to take, you know, sub matrices and stuff like that. But first thing I want to do, right, is probably I want to implement something that will shuffle the rows of the matrix for us, right? So we generated some training data, right? So where is the training data? Yeah, there we go. So we generated some training data. Let me actually even, oh my God, what is going on? I'm just trying to revert the buffers. Thank you so much. Okay, so we generated some training data, and let's actually try to print this entire thing. Why is it twitching? Software in 2023, I swear to God. Okay, so let's try to run this entire thing. What I want to do, I just want to print the training data. There we go. So here is our training data. So, and what I want to do, I want to have a function that will just take all of the rows and shuffle them around, right? So randomly. Is it really necessary to shuffle them? I don't really know, to be fair, right? So maybe this is where the stochastic part of the stochastic gradient descent comes from. But I kind of have a feeling that you don't need to shuffle it. But 3Blue1Brown said that you need to shuffle it, so yeah, who am I to argue with 3Blue1Brown, right? But I have a general feeling that it's gonna converge to like somewhere on average anyway. Like what shuffling exactly doing? I'm not quite sure. Maybe this is something that we can try. We can try to shuffle and not to shuffle, right? So, but we'll see. Anyway, so I'm not too smart to actually understand why exactly you need to shuffle, but anyway, so maybe we're going to implement like a simple function, which is literally going to be called like shuffle rows or something. Let's actually go to the library in here, and so let's introduce something like matrix shuffle rows, right? So, and we're going to accept the matrix, and it's going to just like shuffle the rows of this matrix. Right. So let me actually go in here. So we generated the data, and I'm going to do mat shuffle rows, and then we're going to print this entire thing. And the question is, how exactly are we going to implement this specific function? Right. So the usual way people, like the naive way people shuffle arrays around are just by basically picking two random elements in the array, and just swapping them, right? It's not particularly a great way to shuffle the array, right? So there is a better way. I forgot the name of this sort of like the algorithm, so I think I can Google it up. Algorithm to shuffle array, right? Algorithm to shuffle array. Yeah, Fisher-Yates shuffle. I don't know if I pronounced the names correctly, I'm really sorry. But the idea of this algorithm is actually extremely simple. And it surprisingly makes sense, And when you like realize this idea, you would think to yourself, why didn't I think about it myself? It's just like it makes so much sense. Why a stupid like swap two random elements comes into the head instead of that? It just like makes so much more sense. I don't know why. Maybe for me personally, I can speak only for myself, maybe because I'm stupid, right? So, right, the idea is super simple. The algorithm takes a list of all the elements of the sequence and continuously determines the next element in the shuffled sequence by randomly drawing an element from the list until no elements remain. Right. So essentially, I think there was a better description with the hat, right? So they got rid of the hat recently, I suppose. There was a, yeah, so I think they changed something. So the idea, or maybe bag. Right, so they provided an analogy some time ago, essentially put all of the elements into the hat, right, and just basically draw one by one randomly and arrange them in a sequence of, in order you actually draw them out of the hat. Right, so that was actually a very good description. So they replaced it with this dry, soulless description of having a list of elements and continuously determine the next element in a shuffle. Like, what the fuck is that? So description with the hat, or it was a bag or something, was so much easier to understand than this bullshit. Fuck that. I think somebody changed that, so I don't know. We need to ban that person by IP. So this person shouldn't have an access to Wikipedia. Wikipedia, yeah, needs to sound smart, yeah. So essentially, yeah, basically put your elements into the bag, right? Just like shuffle them around and like take them out of the bag one by one and put them in the order that you actually draw them, right? So, and in case of like an algorithm, how would you implement such algorithm? It's actually pretty straightforward, right? So essentially, you can have some numbers, right? And you can essentially iterate elements from left to right, right? So, and you can maintain a pointer, right? And the pointer can be thought of as the separator between what is already taken out of the hat and what is already in the hat, right? So basically everything starting from that point to the right is in the hat, right? Everything here is in the hat. So everything to the left of this cursor is already out of the hat and it's already sort of like shuffled around. So, and essentially what you would do, you take this range, you pick a random element from that range and you swap it with the current element in here, right? You swap it with the current element in here and you move to the right. So essentially the amount of the elements in your hat decreased by 1 and this 5 is out of the hat. And then you repeat the process. Pick a random element in here. Okay, this is going to be 6. You put 6 in here, swap it around like so, and there you go. And you can do that until you basically ran out of the elements, right? So that's actually pretty cool and actually really easy to understand. So we're going to iterate through the entire thing, and what we're iterating, right, we are iterating through the rows, right? So there we go. One of the things we'll have to do, we'll have to swap the rows, right? So, and this one is going to be rather interesting. So we can basically then iterate by columns and swap the columns correspondingly, right? So, all right, and now we need to do the random thing. So how can we randomly pick an element out of here? All right, so essentially we have 3 elements in here, right? So we have to do 3, we have 3 elements in here. So here are the indices 0, 1, 2, 3, 4, and we have 5 elements. So if I do something like 5 minus 2, it gives me the amount of elements in the hat. Right, it gives me the amount of elements in the hat. So that means I can quite easily just do m rows minus I, and it will give me this entire thing, basically one of the elements in here. But this entire thing also needs to be shifted by I, right? So because it's basically from 0 to 2, right? So it needs to be also shifted, and that essentially gives me the index j, right? The index j, and now I need to swap ith and jth rows, right? But rows is a continuous thing, so I cannot just like swap them around, so I need to iterate through each individual column. Right, so it's going to be starting from 0, then km calls, plus plus k. So, and this is where we're going to be swapping elements one by one. So this is going to be mat at, so m, so row I, k. And this the second thing we have to do, we have to actually swap j. Right, we're going to be swapping j. So interestingly, if it picks this entire thing, maybe we don't need to even do that, but anyway. So I'm just contemplating, do I want to have like a special swap thingy, or do I just do the usual float t, then I just do it like that, and then just do it like that. Because I don't really need swap very often, right? I don't really need swap very often, so I didn't think it makes any sense. So, and on top of that, I think it makes sense to actually check if I not equal j, right? So in case the columns are too big, right? So it would be better not to spend too much time on that. And there we go. So this is basically how we shuffle the rows, right? So this is basically how we shuffle rows in place as well. All right. So let me actually try to compile this entire thing. And hopefully I didn't do any fucky-wucky and potentially an oopsie-doopsie, so everything seems to be okay. So we just like did the swapping in here. That's pretty cool. So another thing we need to be able to do, we need to be able to actually take like several rows from the training data. So we need to perform like sort of like a batch. So do I want to have a special function for that? I didn't think so. I'm going to try to do that without any special function. Right, let's actually not do any special function. But we also need to determine the size of the batch, right? So what's going to be the size of the batch? Right, so let's say batch size. Let's say we're going to have something like 50, right? So this is going to be batch size. And when we're doing an iteration in here, right, we need to actually know how we're going to be doing all of that. So here we are doing several epochs per frame, right? So we have several epochs per frame. But what we're going to consider an epoch? It's basically one iteration over a single batch, or is going to be like iteration over all of the batches? That's a very interesting question. So if we're going to do basically stochastic gradient descent with batches, maybe like epochs per frame is not particularly useful because it's going to be replaced by the amount of batches, right? So we can do all of the batches per frame, which is not particularly probably good idea. I'm not sure if that's a good idea if you have like too many batches. So yeah, so it's probably not going to be a particularly great idea. But one of the important things we need to have anyway is probably the amount of batches at all, right? So this is like a size of a single batch, and then we need to do batch count, right? So how many of them we're going to have. So, and it's essentially rows divided by batch size, right? But it might not be divisible, right? It might not be divisible by this thing, right? So it might not be divisible. So that means we need to actually round it up, right? So we need to round it up. So the easiest way to round it up is actually do plus batches size like -1. Right, so essentially if there is any remainder, it's gonna overflow and the division is gonna be like +1. And if there is no remainder, we add a batch size -1, so it's not gonna overflow, so it's gonna be like cut off by the integer division. So it's basically like a seal, but for integers, right? So this is how I envision that, essentially. That's basically how I envision that. So, and now, how I'm gonna... This is actually very interesting. Right, so I also probably need to keep track of the current batch. Or do I? Do I need to keep track of the current batch? Maybe I can use the epoch as the indicator of the current batch. Right, so since I'm going to be circling through the batches, I can just take the current epoch and do a mod of the batch count. Right, so I can do a mod of the batch count, and this is basically the current batch. Right, so this is going to say st batch current. Right, so this is the batch current. And knowing the current batch, I can actually construct that current batch. Right, and then I can feed that batch into the backpropagation, and then I can like do the cost. But in case of the batch, you know, training and stuff like that, so we don't really know the full cost, and like computing the full cost is kind of like against the point anyway, right? So we don't want to compute the whole cost. We only know the cost per batch. So as far as I know, what people usually do, right? What people usually do, they basically compute an average cost across all of the batches, right? So compute like average cost across all of the batches, and maybe this is exactly what we're gonna do in here, right? So this is probably exactly what we're gonna do in here. Okay, so we've got the current batch. So now we need to construct the data, right? So the input data for this entire stuff. So we already have a TI, so that means I need to construct like a new matrix TI. Though interestingly, it would be kind of easier if I actually constructed them a little bit later, right? So essentially, so we have mat ti. The amount of rows is basically the batch size, right? So this is the batch size. The amount of columns is, since it's an input, so we're gonna have 2 of them, right? So the stride is going to be original, the stride of the t, and this is where it gets very interesting, right? So what is going to be the elements? I think it's kind of easy. So we take the TI at the current row, and the current row is the batch current multiplied by the batch size. Yeah, there we go. So this is the current row, and we're starting from the 0, right? And then we take a pointer at this entire thing, right? So this entire thing doesn't take into account the remainder of the division by the batch size, so it kind of assumes that the amount of batches is actually divisible by the batch size, right? So it's a kind of a bold assumption, but we just do that because we want to simplify things, right? So anyway, and we can do a similar thing in here. So this is going to be the output. So the amount of rows is going to be rows batch size, then it's going to be columns. This is going to be 1, right? So then this is going to be stride, t stride, and the elements is essentially kind of the same, right? It is kind of the same, but it's going to be ti columns, right? So, and that's basically the batch, right? That's basically the batch ti. Maybe I can even call it like a batch ti and batch TO, right? TO stands for training input, training output. And so the next thing I can do in here, I can actually shove them into the backpropagation in here, right? And the backpropagation is going to work on a small subset of this entire thing, like a very small subset of this entire stuff, right? So, and the question is, how do we handle this situation when we're working with the last batch, right? So when we're working with the last batch. So essentially, when, so this is the rows, yeah. So the situation when something like batch size plus batch size is actually greater when it is actually greater than the amount of rows, or actually equal, right? So how do we handle that specific situation? I think that's kind of interesting. So is there any, well, I mean, it should be relatively easy to do that. I just didn't think about it like too much on how to do that. It would be much easier if it was just divisible by the batch size. In that case, I wouldn't have to even think about that. In fact, I can just do that, right? I can just say, okay, so this is the batch size. So it's going to be 28, right? Because we have 28 by 28, so it should be relatively straightforward to actually do that. In fact, maybe we can even print all of the batches right away. That would be kind of interesting, so I can iterate through all of these things, right? So batch count, right? So this is going to be batch count, and I just want to see all of the batches in here, right? So we're going to put them in here, right? So it's going to be matrix print batch ti and batch to, right? So, and let's give it a try and see if it's going to work or not. So batch current, it doesn't really like, oh, because batch current is actually I, right? So size t batch current, and this is going to be I. There we go. So ti columns, this one has to be batch ti. All right, so let's go through this compilation error. So this is going to be batch ti. What else do we have in here? I can't see what is going on in here. So, and it also prints the cost. So for now, I'm going to disable printing the cost, right? Because it's not going to tell us anything. Right, and let's just try to run it. And it didn't really produce anything useful. This is because it would make sense to actually stop after we printed all of these things, right? So I supposed to actually put 0 in here. Right, so this seems to be pretty legit. Okay, so that's actually kind of cool. That is actually kind of cool. So yeah, so the problem I have in here is that I want to do like I do everything. I do the training and rendering in a single frame. That's a huge problem, right? So in a single thread, I'm sorry, in a single thread. So that means I have to kind of juggle between like amount of operations I do per frame. I don't want to do too many operations. And so essentially I have a frame. Within a single frame, I can do several batches, but I also want to consider a single epoch as going through all of the batches. Right. So because once I went through all of the batches, I can compute their average cost and kind of give you the cost information that you can put on a plot or something like that. So I have frames, I have batches, and I have epochs. And I'm not sure if epoch is like a single batch or it's a round of batches, right? So I don't know if it's like a round of batches or something like that. So I don't know the conventions. I'm not an AI person, I'm sorry, right? I know that there are traditions, there are conventions and stuff like that, but I kind of want to separate the notions of the epochs and batches, right? I think it kind of makes sense, at least to me, right? To the person who never actually worked with this entire stuff. Right, so, and because of that, I think here we're iterating through the epochs, but I don't want to do, so I need to introduce batches per frame then. So I need to have something that is called batch per frame. All right, so let's go ahead and do that. So epochs per frame, so it's going to be size t, batches per frame. So let's say that we're going to have maybe, I don't know, 28 batches per frame, right? So we're gonna have 28 batches per frame, so essentially we can keep track of the current Man. I really need to think about it, right? I really need to think how exactly I want to organize that. It's not really easy, right? So I think I need to make a small break for that, right? So I'm gonna make a small break. I'm gonna make a cup of tea, and while I'm making a cup of tea, I'm gonna think about it, how I want to organize all of that, and then we're gonna continue. All right. Okay. So I've got an idea, right? I've got an idea. What if we essentially keep track of the position of the beginning of the current batch, if that makes any sense, right? So we start at here, and this is sort of like, this is where we start. We know the size of the batch, right? So we know the size of the batch, so we say, okay, so the batch starts from here, and then plus the size, and this is our batch, we process it. And then after processing it one time, we increment that counter by the size of the batch, so it now points at here. Right, so and then we continue. If there is this small remainder, it is easily detectable because the current sort of cursor plus the size of the batch overflows the amount of batches, right? It overflows the amount of batches, and it's super easy to detect, so we can just cut it down and how to say that? And do something special on that, right? So essentially, one of the things I want to do once I processed all of the batches, right, I want to compute the average cost, right? So I want to compute the average cost and simply add it to the plot, right? So because I want to be plotting the average cost, right? So since we don't compute the full cost, the only thing we can do, we can compute the cost for that batch, then for that batch, so maybe cost 1, cost 2, cost 3. Then at the end of processing all of the batches, we can sum them up and divide by the amount of batches, right? And that's how we get the average cost, right? So it's not exactly going to be the cost, but it's something that is very close. It is on average, as on average we're convergent just by processing batches or something like that, right? So all of that is sort of an intuition, right? So, but we'll see how it will work. We'll see how it will work. So, okay, so we have batches per frame. This is a very important metric. I want to actually, this metric to be specifically not equal to the amount of batches, like to be something different. That's what I'm trying to say. So here's the batch size, here's the batch count. I'm not sure if it's going to be useful. It could be useful for computing the average cost, so I'm going to keep that. Right, so, and we can keep track of the something like batch begin. So where does it start? Right, it starts at 0, right? So it essentially starts at 0. Right, okay, so this is basically where we're computing all of that. So, and in here, right, and in here, what we're trying to do, we want to do batches per frame, bat chest per frame, right? So we're doing bat chest per frame. While we haven't processed all of the batches in the frame, we're not paused, and we didn't run out of epochs, right? We didn't run out of epochs. What we're doing, we're trying to compute the size of the batch. So the batch starts at essentially batch begin, right? So this is a batch begin, and this is another batch begin. So this is where it starts. I also want to get rid of this entire thing that was printing the all of the batches. I don't think it's useful anymore, right? I don't think it's useful anymore. And all right, so one of the things that we need to detect in here, right? So there's no batch current anymore, it's not particularly useful. All right, if batch begin plus batch size, right, batch size is greater or equal to the amount of batches, right? So that that specifically means, right, that specifically means that we are on the last batch, right? That specifically means that we are on the last batch. So, which is rather interesting, right? Which is rather interesting. How that also means that the actual size is going to be slightly different, right? So we have the actual size, and this is the batch size. And if we overflow, so the actual size has to be more of a like t rows minus batch begin, right? To account for that specific size. Right, so essentially if we have, so this is like the rows, so the batch size is, let's say 2, right? So, and the indices of the batches are 0, 1, 2, right, 2, 3, 4, right? So here we have 0, right, so this is what we're pointing at, and plus 2 is gonna be still less than amount of things, so it's going to be fine. Then plus 2, it's going to be fine. Right, so here when we 4, plus 2 is going to be obviously greater than the amount of rows. So what we'll have to do, so we have 5 of them in here, 5 minus 4 is going to be 1, and that's the size, the actual size in here. So this takes care of the remainder easily. What if it is divisible by this entire thing? We're going to stop at here. So 2 plus 2 is going to be 4, so it's going to overflow. That means okay, so that takes care of all of that. Right, so this specific approach does in fact takes care of all of these things, right? So that means here we can actually say that the size is going to be literally this, right? But that also indicates that this is the last batch, and after that last batch, we have to do something, right? So we have to compute the cost and whatnot. Right, so essentially how can we do that? So maybe we could have something like last, right, and here it becomes true, right, and essentially here we process in the batch, right, so here we process in the batch, and essentially if last, right, if last we increment the epoch, right, and we need to also append the cost in here that we compute in a very specific way. Right, so we compute that cost in a very specific way. So let me see. So we can actually do something like float average cost, which is initially 0, right? It is initially 0. So we did a backpropagation, right? We did a backpropagation, and then we do cost on the same batch. We're doing the cost in the same batch, but we also add the cost in here, right? And if we are at the last batch, we take the cost and divide it by the amount of batches, right? So batch count, right? And there we go. We also have to reset it to 0 because we're getting on the next round. Right, we reset it to 0, and on top of that we have to do batch begin, we have to reset it to 0 as well, right? So all of that, it feels a little bit complicated, but because it is, right, so we want to be able to do several batches per frame, but we're not going to finish all of the batches in a single frame, right? So, but then yeah, so does it make sense why it is this complicated, right? Because I introduced the notions of batches, epochs, and frames, right? So we have two separate, like 3 separate notions that can be out of sync with each other, right? So I want to have a fixed amount of batches per frame. A single epoch is like a single round of batches, so you cannot finish an epoch on a single frame. So all of these things can be out of sync with each other, right? And we can only compute a cost after we went through all of the batches, because we added up all of the costs of the batches and divided by the amount of batches. Does it make sense? Right. So, and also maybe I'm overcomplicating things unintentionally, right? So I don't know, right? So let me know. So maybe I am overcomplicating things, but we'll see. Right. And in terms of, okay, so we also have to do probably batch begin plus batch size. There we go. And by the way, this is where we can kind of detect that we are at last thing without having the last stuff in here. If that makes any sense, right? So if we remove the last, we can kind of see if batch begin is greater or equal to the amount of batches, so this is the last, we don't really need that boolean variable anymore, right? So we don't really need that boolean variable. Okay, that looks okay. So we add the cost, so that also means so here we're computing the cost, but I'm not really sure how useful it is in here, right? So I can't really, yeah, I can't really print that cost because it doesn't really make any sense. All right, let's go ahead and try to compile everything we have in here, because I think I kind of nailed it down. Right, hopefully. So batch to O, so it doesn't like something. Too many arguments for NN cost. I'm really surprised why. Oh, because it doesn't accept the gradient. It doesn't really need the gradient at all. Okay, so cost. So it's actually average cost. Average cost. All right. So, and we don't use epochs per frame anymore, right? So that makes sense. That makes sense for sure. And to be fair, it could be like, yeah, so the funny thing is that if you have too many batches per frame, you can actually go through several epochs in a single frame, and that would also work, right? Because all of these things can be out of sync with each other. All right, so everything seems to be fine. So I think I'm ready to just try to run this entire thing and see how it goes. Right, okay, so it was not complaining about anything. All right, so I'm a little bit scared, so let's give it a try. So it is actually flickering. I don't know why. I don't really know why it is flickering, honestly. But it's going down. So I guess epilepsy warning for this specific thing. All right, so it is going somewhere, which is surprising to me, in my opinion. Right, so let's say that we're gonna have batches per frame. Like, let's say we're gonna have 100 batches, right? So per frame. So that means it should actually go really fast. Why is it learning so freaking fast? What the fuck? This is such an effective... Holy shit, why didn't I implement that earlier? What the fuck? That is so fast! Even when I'm straight... That is beautiful. This is... And look how accurate it is. Right. Like, I'm a little bit... Yeah, unsettled by flickering in here, but maybe that's by design. Maybe that is by design. And this is an average cost, by the way. That's why... Sometimes it can go up, by the way. Sometimes yeah, this thing is stuck a little bit, I think. Right, I think it's stuck a little bit. Yo, that is so cool. Alright. I love that. Too good to be correct, yeah. So we can try to increase the amount of epochs per frame. So what about 200 of them? Whoever came up with an idea of stochastic gradient descent and splitting this entire shit by batches is a freaking genius. I'm telling you. Right. It's only was like 6,000 epochs. Right, so 6,000 rounds around all of the batches, and it converged beautifully. Like, it converged beautifully. So, like, what the fuck? This is so awesome. And it's even more stable than whatever we had before. Like, holy shit. Maybe the learning rate too high. Maybe in case of a stochastic gradient descent, you don't really need that high of a rate. So let me actually try to reduce it in half at least. Right, so yeah. I guess the fact that it's pulsating is because it's stochastic, right? Alright, so let's actually try other numbers, right? So we have the second number in here, which is 6, right? So let's see how it's going to behave in case of 6. Alright. So 6 is a little bit more difficult for it to learn because it has like this weird loop. Right, you see it's struggling with 6 usually. Right. But it learned like in a pretty decent level how to imitate 6. And this is something that it couldn't do, for me at least, with like the usual thing. Man, this is awesome. I really like that. All right. So that means, and again, this is on a 10 years old laptop, from which I'm also streaming. Right, I'm also streaming. And Twitch, when I'm streaming, actually works like the website Twitch is actually lagging very badly, right? And it made this entire thing speed up dramatically, so to the point that I can actually work with that, right? So it's actually usable. Right, it's actually usable. So my learning rate is constant, yeah, for now. Maybe we'll come up with something like more dynamic, but for now I think it's fine, right? Anyway, so what I want to do, I want to actually accept 2 images now, right? I want to train on 2 images. So how are we gonna do that? So before I actually do this entire stuff, I think I want to commit whatever I have already, right? So I think it's gonna be kind of useful. So here I made this sort of separation on input and output. I don't think it's needed anymore. So here is the batches per frame. So here is the size. So batch count, I'm not sure how useful batch count is. So interestingly, I want to be able to display an average cost somehow. Right, so at least at the top of training thing. But here's the interesting thing. At any point, I don't really know the current cost. Or do I? I have a plot, actually. Yeah, I have a plot. I can take it from the plot. Yeah. So let me quickly do that. So the thing I literally can do is something like cost f, right? If plot count is greater than 0, right? If it's greater than 0, that means I can do just plot data plot count -1. Otherwise, it's going to be 0, right? So I can literally take the last value from the plot, right? So and it's going to be fine. Hopefully. So essentially, this is not how I use ternary operator. You were supposed to put a question mark in there. Okay, so what else do you want from me? So this is items, I suppose. Okay, so that seems to be working. And now I can see the cost. It's really useful for me to... It goes down so freaking fast. It's insane. Oh, as you can see, sometimes it just like starts to spike. Yeah, it found some local sort of optima and it's just like going around the circles, I suppose. That's why it keeps spiking and stuff like that. We can try to restart this entire thing. But I really like how you can see the stochastic nature of the whole process. Right. I really like that. That's so beautiful. Anyway, so then we can take a look at the upscale, and this is upscaled version. It's really struggling to capture this loop, if you know what I mean. It kind of struggling to capture that. It's the most scuffed thing I've ever seen. Holy shit. All right, so that's cool. So let me do a committee. Okay. And so I don't think I'm gonna commit that. Image to NN. Implement stg. Right, and I'm gonna push that right into the repo, so we've got some sub. Thank you so much, Killer Rexu, for Twitch Prime. Thank you. What if we would reshuffle training data after last batch? That's also an interesting idea, right? So to introduce even more random, that already kind of makes sense. All right. So just shuffling it like before training doesn't really make much sense because it's just a different order of the data. What's the point? Right. So that's why I was like very skeptical. What's the point of shuffling before like doing that? Because it's like it's going to stay the same. But shuffling it every round, now that makes sense because it introduced like actual randomness every time. Yeah, thank you so much. That's an interesting idea. So I think this is what we should try to do. Right, so that already makes sense to me. Okay, so let's actually not even shuffle it at the beginning, right? Let's not even shuffle it at the beginning, and then at the end, just shuffle it, and let's see if it's going to like change anything. All right, so it's so much. Look at the average cost. Yeah, now we can see that it's shuffling it. But I mean, it converged like quite well, I suppose. And by the way, since we're doing stochastic gradient set and it's so fast, maybe we can just give it more, you know, neurons to work with, right? So what if we just do something like 10 by 10 or something? Okay. Yo, what the fuck? I mean, it just has more neurons to actually work with, I suppose. Right. I guess. It still has this, like, sort of, like, weird tail. Right. Yo, that is so cool. Just stir the pile. Exactly. Just stir the pile. I don't really like that it's not smooth, but I guess if it works, I mean, who cares? Yo, this is perfect. It found a perfect representation of this shit. I think it found it. It's getting better and better and better. Look at that. Indistinguishable. Indistinguishable. The AI got so good you cannot distinguish the human written and AI written. Look how good it is. It behaves just like human. Holy fuck, you cannot distinguish them. Anyway. Right, so if we take a look at upscale. Anyway, so let's stop fucking around. Right, so we have a very specific goal today. We want to combine two images together. And that's the goal for today. Right. That's the goal for today. All right, so how are we going to be doing all that? I think we need to accept two images now, right? So input one, let's put it like this: image one, image two, right? No image one is provided. No image one is provided. So this is going to be image one file path. So after that, we can say no image two is provided. And here we can have an image two. Right. And I suppose starting from like here up until the end, it would be kind of nice to replace image with image one, right? So can we just like mass replace this entire? Okay, I'm gonna mass replace, hoping that it's going to like at least work. It probably won't. Okay, so it in fact worked. Okay, so we're gonna start with providing the 8, right? So this is gonna be 8, and then we're gonna provide the second thing, training 6, right? So we're gonna provide both. Yesu, kawaii freaking desu, so everything seems to be working. I love watching it, how it learns. And it's like, yeah. So the problem with the previous learning process was that it was not always finding the configuration where it would put 2 holes into the 8. Now it finds that configuration every single time, and so fast. Right. Well, sometimes, yeah. So it's actually kind of good. Man, that's so fucking cool. Anyway, I'm sorry. Right. So now we are accepting everything, right? So we read the first image in here, right? So we read the first image. So the next thing we need to do, we need to read the second image. So I need to replace image 1 with image 2. So, and we just read the second image. How about that? So we can even maybe like print this kind of stuff here, right? So maybe I'm gonna just do return, just to see if it worked successfully, right? Okay, so it managed to read both of the images into the memory, right? So what are we doing here? Okay, so here we constructing the data, right? So the training set. So the amount of rows is the amount of pixels of the first image. Essentially, we need to double the amount of rows. Right now, we have the pixels of the second image as well. So this is the amount of rows we have, right? So we have even more training data now. So the amount of columns is actually going to be 4, right? So we're going to have 3 inputs and 1 output. So that's basically what we have. So we're adding the pixels of the first image into here, right? So this is going to be that. So the index is just this, which makes sense, right? So which in fact makes sense. So here is the input, here is the output, and essentially the second value has to be 0, right? It has to be 0 because it indicates the index of the current image. And the third value is the output, which is the brightness of this entire thing. Okay, so now what we're gonna do, essentially, we're going to handle the second image, right? So this is gonna be image 2. There we go. But now we have to actually offset the index, right? So we have to offset the index by image 1 width multiplied by image 1 height, right? So we offset this entire thing. And that should give us like a bigger training set, right? So let's do matrix print, and this is going to be t, and let's actually exit it here, and let's marvel at the size of this training set. That's a huge ass training set, right? So how many things we have in here? Like 1,500, like exactly as we expected, right? So because it contains both of the images, right? So look at the third column. This is the index of the image, right? So this is the pixels of the first image, right? That makes sense. And yeah, the pixels of the second image, they should have this thing equal to 1, right? So this they should have this thing equal to 1. And I think we managed to capture the data correctly. Okay, that's cool. We can already try to sort of train this entire thing, right? So we can already try to train this entire thing and see how it works. But we don't really sample this image correctly, so that's kind of the problem. Right, is it... Oh, it's actually kind of stuck. Huh. Does it just mean that it doesn't have... Huh. Interesting. I suppose we probably also want to specify the index, right? So in here, we're going to do a start with 0 in here. Then we're going to forward this entire thing, and it should give us this entire thing back. So I have a feeling that maybe what we have to do, right, is... so the sampling is correct. Maybe we should just give it more... neurons and stuff like that. Maybe we should just give it more neurons. So it really cannot learn, or it doesn't really go anywhere. Okay, so let's do the architecture. So this is going to be 7. All right. So let's maybe add more things in here. So adding more things is not particularly useful, I think. Oh, it has 2. Yeah, that's actually a good point. Why does it... Oh, okay. So, yeah, that was a stupid mistake. How did it work then? Wait, how did it even freaking work then? Yeah, that's kind of interesting. Right, so there should be... Yeah, thank you so much. There's like 3 inputs in here. Right, so there's like 3 inputs. And in here, in terms of TI, there's going to be 3 inputs in here. There's a lot of places where that I have to modify every time, which is kind of dangerous. Right, if you think about that. Now we're freaking... Okay, so that makes sense now. Now it behaves like... at least it tries to behave like 8. Right. So what's interesting is that it also on the at the background also tries to act like 6. So it tries to act like 6 and 8 simultaneously. Right, so that means when we're sampling it, when we're sampling this entire thing, right, so let me see. So this is gonna be just like 1, right? So without changing the like anything, we should be able to see how it behaves like 6, but it doesn't. Huh. Alright, so there's... It kind of... Okay, so it kind of tries to do something. So there's something wrong maybe with the cost. I need to really go through like the entire thing and make sure that we have like the right amount of the inputs and outputs and stuff like that. But the fact that the cost going way down, that means that in there it actually acts correctly. So what's up with... Yeah, this thing should work correctly in my opinion. Right, it literally should work correctly, and it should give us something. It should give us the second image, right? So yeah. So the fact that it goes so low, means that, yeah, there's something bogus in here. But if we look at this thing, it works correctly. All right, that's cool. Okay, so let's actually go through the entire source code and let's make sure that there's no, wrong things anywhere. So we pre-allocated. So this is how many of these things we have in here, right? So we have 3 inputs and 1 output, right? So that's essentially what we have. 3 inputs and 1 output. Maybe what we have to do, let's actually put architecture somewhere like at the top in here, right? So let's put architecture at the top in here, right? And so essentially, where is the training data? Where is the training? I can't see the training. Yeah, here it is. One of the things we can try to do is probably maybe arch 0. So this is the inputs and the arch. Though interestingly, it would be way easier if we constructed these things first, right? So if we constructed the neural networks first, right? So that way, what we could do is just like inputs of this thing, the amount of columns, right? So this is the amount of columns, and the outputs, and then the columns, right? So that way we don't really have to update that. Right, so that's basically what we have in here. Inputs and outputs. So this is that. This is that. So that's actually way better. Okay, so here we're just constructing the window, nothing particularly special. So there is a preview image, right? Preview image. Maybe one of the things we want to do in here is actually name it preview image 1, right? So because maybe I want to actually do several of them, right? So because maybe I want to like view them simultaneously, but not for now. We're gonna do that a little bit later. So then I basically copy the original image in there, then I load the texture, and everything seems to be okay in here. Everything seems to be okay. Okay, so here's the batches. Everything seems to be fine in here. So this is the input. In terms of the input, so I construct the preview image, right? I'm just simply constructing preview image. So I put X and Y in here, and then the index 0, 1, 2, and that should be it. Then I forward this entire thing and I get something back. So that should be fine, and then we just render it. And in here, we're just printing the original thing, and then this thing, right? So, which also means that I have to probably do something like this. So here I have to put 0, and then I'm gonna get an output. And then in here, right, so we just do something like this, and yeah, we get an output. Right, don't see any errors, right? So everything seems to be okay. So let's try to train it one more time. So I don't really know why the second image wouldn't work. It's almost like it's just keeps... Do I rebuild whatever I haven't? Yeah, I do rebuild, okay. Because otherwise it wouldn't work, obviously. Alright. Because I'm pretty sure it would affect the cost. Alright. So that seems to be working, and in terms of upscaled, it managed to do something. So where is the... Okay, so the 6. Surprisingly... Okay, so what if I swap them around? What if I put 1 in here and 0 in here? How is it going to behave? How is it going to behave? Okay. It's almost like... I'm not sure what exactly is causing that. Like, I need to be 100% sure that this is not a bug. Right, so I need to be 100% sure that this is not a bug that I somehow... is the offset of... What do you mean? Yeah, it feels like something wrong with an offset. Right, it does feel like something wrong with an offset. But it's kind of difficult to tell what exactly could be wrong. Maybe I need to make another small break, right? So I need to think about what could be wrong in here, right? If this neural network cannot do what I'm asking it to do, why does it work only on the first image but not on the second? And on the second it just like feels really weird. And if it can work on the first image, why by swapping the indices it still cannot show the second image? So there must be something wrong with the way I'm approaching this entire thing. So there must be somewhere a bug in here. I'm pretty sure about that. So image, so maybe I have set this thing incorrectly. Right. So because, yeah, it learned this thing perfectly. Right. But for the second image, it's incapable of doing that. All right, so let's make a small break. Right, and after the break, right. And after the break, we're gonna see what we can do. All right. So let's try to figure out what the fuck is going on. So one of the things that was suggested on the break is to actually swap the arguments around. So let's actually see with the usual order of the arguments, right? So that it learns to be an 8, right? We can clearly see that it is in fact an 8. And okay, maybe because of this thing being a 0, that specific neuron does not even activate anything. But I mean, there could be a bias anyway, right? So there's still a bias for this kind of stuff. So I don't think it's that big of a deal, right? So, all right. So let me try to do that. Okay, so let me see. Okay, so it does in fact act like 6. So maybe there is something about the index 0 specifically. Right, maybe there is something about index 0 specifically. That's actually a good question. What's up with that? That is very interesting. How we made this so fast? I just used stochastic gradient descent now. That's the way I made it go fast. That's the way. Okay, so if I try 6 now, right, if I try 6, right, it is being 6 and everything. And now, when I'm displaying this entire stuff, I'm going to set that to 1. Right? Yeah. It's doing something. Yeah, it's still kind of out of bounds. So that might be not a bug. That might be not a bug. Fortunately or unfortunately. What I'm thinking is that, what if we just don't use 0? Right, what if it's not a 0? What if it's not a 0? What if it's going to be like a half, or maybe 25? And here we're gonna have a 75. So interestingly, so here we can put 25. Is it going to even remotely work? Is it going to even remotely work? Okay. It is trying to be 6. Which makes sense. Okay, so that's fine. But then it kind of like, you know, struggles to do anything. Alright, so it doesn't really go that much down. But now, if I do 75 on that thing, is it gonna act like something else? Maybe it just like simply doesn't have enough yeah, enough neurons, right? So it doesn't have enough like power to just like produce anything. So what if we make it a little bit deeper, right? What if we give more layers? Though we're using sigmoid, and as far as I know, the problem with sigmoid is that it kind of like, the more layers you have, the more it sort of like vanishes. The gradient slowly vanishes, so it's not going to be that useful. Though it's rather fast, right? This straight up looks like a bug, like holy fuck. Alright, so something else is wrong. Yeah, that's true. It's just like, it's so sus. It cannot be true. Like, I don't believe that there is no bug in there. There is some sort of a bug, but I fail to see that bug. Alright, so we have a preview image. So maybe I'm gonna say this is a preview image 1, preview texture. Original image, but this is an original image 1, and we have original texture 1, right? So we're gonna have these kind of things. Right, so let me see. We definitely, so let texture for preview image. This is a preview image 1. So this one has to be a preview image 2. Right, so that's what we have to have in here, and this one is image 2. And then we have a similar stuff, so it's just like instead of 1, we have 2. Make sense? Makes sense. Okay, so let's go to the compilation errors. Why would be stuck on top only? Yeah, that's a good question. Like, what exactly is going on in here? Redefinition of preview. Yeah, so this one has to be 2. Okay. Original image 1. What else do we have? Original image 1. So this one has to be 2. God damn. So this one, do we have ones? Okay, so there's only 2s in here. So preview image 1. So this one has to be 25. Image 1. Can it be possible that there a number of zeros in training data is way more than the number of actual data? No, we're zeros because we're computing the difference. Cost function is computed by the difference of the actual data and expected one. So whether it's 0 or not, it doesn't matter. It simply doesn't. Right. If it deviates from what we expect, it's gonna affect the cost function negatively, regardless of what we're like doing or anything. Okay. So we need to construct this thing. So I need to replace 1 with 2. So I'm gonna replace in that. Well, that was kind of bad. So what I have to do in here is this. So this is 75 now. Okay, so it's doing thing. Now I wanna render like the pair of other things in there, right? So I updated this thing, and now I'm gonna be updating preview image 2, 2, 2, 2. But now I'm gonna be rendering them. So this one is actually image height 2. I'm gonna offset them by image 1 width multiplied by scale. So yeah, it's gonna be offset to the right. So, and the question is, what is a scale? Can we make it a little bit smaller? Maybe like, maybe 10 is gonna actually fit all of that there. Okay, so this is what we see in here. So I think it's Yeah. I kind of refuse to believe that it cannot accommodate that, because effectively what we're doing, by the way, chat, we're storing three-dimensional image, aren't we? We're storing three-dimensional image, right? So basically the third input is the third dimension. So how is that different from just two-dimensional one? And this is basically the slice of two dimensions, right? I fail to see how is that just won't work, right? I literally fail to see how that won't work. Do you have enough neurons? Maybe I don't. We can see the amount of neurons on the screen. Actually, we can just like make it bigger. Like let's make it 28 by 28, like literally the size of the images. Maybe it will figure that out somehow. That's basically all of the neurons that we have. Could it be that extra dimension acting like a bias parameter? Not sure. And it's surprising that for the first one, it works kind of perfectly. Maybe I messed up the data somehow. Maybe I messed up the data. So width... how would it react with two the same images? Yeah, that's a good question. 6. So it feels like there is a bug. And maybe it's even a visualization bug? Yeah, that's a good question. Thank you so much. Yes. That's a good question. This is exactly why I don't understand. Why the cost is so slow or so low when they correct only half of the data. Exactly. That's what we're trying to figure out. That's a very good question. And also why these biases are so... And look how good it is. Like the cost... Look at that goddamn cost function. I could have not dreamed about better cost function in my entire life. Like, what the fuck? So what is going on? There must be... Maybe I just don't put enough data in there? Like... Dude, this is so bad. So Matt at I2, where? So you found an error, but where did you find an error? Holy shit! Okay. Okay. Oh my god, you are the hero. Wash Benzin, I don't know if I pronounced your nickname correctly, but you are a goddamn hero. Holy shit. Thank you. Goddamn legend. Goddamn legend. Okay, you are getting a goddamn VIP, I swear to God. So people who are not being helpful are getting timeout. People who are helpful are getting VIP. Right. So can I autocomplete? Yeah, there we go. So you're getting VIP now. Thank you so much, sir or man. Yeah, cool. Okay. So now let's actually go back to original like index 0 and index 1, right? So because that's gonna be very interesting. So and like such a simple stupid bug, like I told you, right? So I told you from the beginning, it's something stupid. I have enough experience in software development. I can sense the stupid bug, right? My software developer sense starts tingling. I can sense it. It's something stupid, right? It's a typo somewhere, but thank you so much. Alrighty. Because I've seen enough software bullshit over the 17 years or already 18. I don't know for how long I've been doing this entire scheiße, but used to. All right. Okay, so let me try to now put the second number in here. Right, and we should have two separate numbers. All right, and look at that. Yeah, that's exactly what I'm talking about. So there's two slices, two separate slices of three-dimensional space. So this neural network acts simultaneously as 6 and 8. Right. It acts simultaneously as 6 and 8. So what's interesting is that not all of these things are engaged, and probably we don't need that many neurons in the first place, right? So we were adding neurons because we were not sure what the fuck is going on. I don't feel we need that many of them. What if we just like use the original architecture that we used for a single number? Right, so this is what we use for a single number. I wonder if it can compress actually two numbers into the single architecture. Yeah. Okay, so it's trying. It's actually kind of doing something. It kind of can. Like, it figured out 6 to some extent. It's struggling. Yeah, it managed to actually compress something, right? So this is basically what it managed to compress. Also, let me actually make the scale a little bit smaller. Right, so maybe 8, right? Because I want to actually, you know, see everything on the screen. Yeah. Man, this is so fucking awesome, holy shit. Even though it doesn't have enough neurons to actually model this entire thing, it's still freaking awesome, right? That it can do like both of them, and it's like around here it starts to struggle a little bit. Okay, so what if we make it a little bit more powerful? 7.4, let's actually add a couple of things in here. So how 0.5 looks like, just a second. Okay, well, I want to find a minimum architecture where it can learn both of them. Alright, and then we can try to do half. Alright, then we can try to do half. This doesn't look that bad, so it looks kind of good, I think. It's still kind of scuffed, honestly. What if I add like another layer? So it goes a bit deeper now. Yo. So what if I add this stuff in here? What if we have 9? Cost in real time. Slow learning rate. I don't think the problem here is in learning rate. It's a stochastic gradient descent, right? It's supposed to be this spiky, I think. At least. I'm just coping. I'm simply coping. That's kind of cool. That's kind of cool. I mean, it's, yeah. it encapsulated both of them. All right, so what here at the end of the execution, we're rendering one of the images. What if this is where we're gonna render something in between, right? Right. So what if this is where we're gonna render something in between? Actually, yeah. Actually, we can put that stuff in both of the places. Right, because we also have upscale, so we can also see upscale thingy. So we're about to render something in between. So we need to basically pick the best training model that we've got. So let's try to train something. Okay, let's try one more time. That's a good one, I think, more or less. Alright, I think it's kind of stuck in here. Okay, so we're gonna stop in here, and in console it will show us what's how in between of them looks like. So this is a thing in between. It's kind of difficult to see in number, but it looks like Moncat.os. Anyway, okay, so we also have upscale version. So yeah, this is something between that 6 and 8. Right. So, which is kind of cool, right? So, it just like merged two images together, right? It basically sexed, right. My neural network is haunted. One of the things I want to do is I want to be able to just like put two images together and move between them, if you know what I mean. Right, I want to be able to move between them. So I wonder how can I easily do that? Because that requires to have a view, special view, and a slider, right? It requires to have a special view and a slider. But having a slider would be actually so cool because like it could be interactive. Okay, so let me start the UI and see where we can put that into this stuff. All right. So we could have put it somewhere in here, down below, right? I'm not sure if you can see that, but yeah. We could try to put some stuff in here. There's not that much place. That's the problem. Okay, so we can maybe make a scale dependent on the width, if you know what I mean, right? So if we have on the height actually, so height multiplied by 0.5, right? So let me see. So that's gonna be our scale. It's too big. You can already see that. If you run multiple times, does it produce similar intermediate images? I don't know. We're about to find out. So can I just put one in here? I'm trying to figure out from the UI perspective where exactly I'm going to put this entire stuff. Okay, so this thing adapts automatically. Right, so I think I need to put another image down there, right? Another image down there with a slider as well. Right. Okay. So what we need is a preview image. So we have a preview image 2. Let's actually literally create a third one. Let's literally create a third one. We're using the existing sizes in here of existing things, but I don't think it's a pretty good idea. So let me maybe introduce special things in here. So this is going to be preview width, and it's going to be 28, and height by 28. So it's going to be the same for all of them, hopefully, right? preview, preview. So I wonder, yeah, preview width and preview height. So original image, it is also, well, original image has to be this way. The original image 2 also has to be this way. Yeah, that makes sense. So, and for the preview, for the third one, I'm gonna put this thing in here. Can we replace image 2, image 3? Yep. So this one is gonna be half, and the third one is gonna be rendered essentially at yeah, we don't need original in here to replace 2 with 1, except maybe vector. Why 1? 3? It has to be 3. What the fuck are you talking about? So x is gonna be that, but y is gonna be that. So this is that, but we also have to multiply by 2 because we're gonna go a little bit down. Right, so this is gonna be the third one. So image 3, yeah, all of that has to be preview. Preview width and height. Preview width and height, and also the same for these things. So could replace image 2 preview, right? Because it's the same for all of them. Could replace image 1 preview. And let's give it a try. Okay. So this third value, the third image is going to be something in between. Must be something in between. But it doesn't work. What the fuck? Because it is not 3. It is 2. Okay. Right, so this is something in between them. This is kind of interesting, so we can try to restart it one more time. So it's a... yeah. Generating alien alphabet. So this is not the coolest thing in here. The coolest thing would be to see the transition from 0 to 1. That what would be cool to see, right? I want to literally see that. So here we can actually have this sort of thing. So let's call it scroll maybe, right? So this is going to be a scroll, and this is going to be a separate sort of variable that we can have in here. So this is going to be a float scroll, and initially it's just like a half, right? And essentially what I want to have some sort of a slider that indicates the value of scroll, if you know what I mean. Right, so we can put it somewhere down below. I need to be able to draw a rectangle, right? How can I draw a rectangle? So let's find the array leap thingy. This is going to be array leap, draw rectangle. There we go, that's what I wanted to have. Can I draw a rectangle with the vector? Thank you so much, array san 5. I really appreciate that. Array san. So the position is going to be like at here, right? So that's the position, and it has to be actually 3 in here. So what's going to be the size? We're going to put collateral. Also, I want to add a little bit of a padding. Right, so this is going to be float pad, and let's say it's going to be it could be our h multiplied by 0, 0, 0, like 1 or 2 or whatever, doesn't really matter. Collateral vector 2 size, I suppose, is going to be so in terms of like x, I suppose it has to be this width, but multiplied by maybe 2, right? It's going to be width of 2 images in here. And in terms of height, let's say it's gonna like have our h000 like 4 or something, right? So I'm making everything dependent on the height of the window, so when I resize it, it also resizes along, right? So that's basically the idea here. So, and in terms of the color, let's actually make it red for now, just so we can see how this entire thing looks like, right? Okay, this is huge, absolutely freaking huge. I'm actually quite surprised how huge it is. So yeah, I suppose if this is the size, it has to be like this, and this has to be like this, right? That's the mistakes I've made. Stupid fucking mistakes, man. Yeah, there we go. So, but it's too thin, I think. It's too kind of thin, so let's make it a little bit thicker, just a tiny bit thicker. Okay, so that's a bit better, but could have been smaller, like half of that. Also, padding is too small, right, so I think I can make a similar padding. By the way, I stole the idea of this sort of like relative units relative to the window from Jonathan Blow. It's basically when he develops like user interface, he usually does things like that, and it's super convenient actually. It's a very easy way to just like make resizable adaptive UI, if you know what I mean. It's like I never thought about it, right? So just think about not in terms of pixels, but in terms of these relative units, right? And like in terms of these relative units. All right, so we have this entire thing, which is particularly nice. Okay, so and it would be nice to have on top of that also some sort of a slider. Right, so some sort of a slider. So I want to like encapsulate this entire thing so it doesn't leak too many like variables in here. So let's introduce the width of this entire stuff, right? So this is going to be the width. Might as well actually literally just use vector2 size, right? So vector2 size, and just use this thing in here, like so. And this is the size. So then, if I want to render another thing in here, it's not very adaptive, but scalable and good enough in many cases. Depends whatever words you want to use. Sure. Anyway, so where we want to put our thing, right? So we want to now put a knob, right? So we want to put a knob. Where are we going to put that? So I think I'm going to put it in the form of a circle, right? So draw circle. Can I just use circle V? Okay, so that's pretty consistent. And we want to put it starting at X, but it's going to be plus size X multiplied by the scroll, and the scroll is the value from 0 to 1, right? So that's basically what we have in here. So in terms of y, y is gonna stay the same. So maybe I'm gonna do a position, right? So this is gonna be a position. Position size. Okay, so this is the scroll, and position is going to be just you know, y. In terms of the radius, let's say that the radius is going to be also our h, but 0. Actually 1. We can, maybe it's going to be too big, but maybe yeah. So this is the radius, and let's make the color maybe red. But in this case, I think I want to make this thing white, right? So slowly building up the UI thing. And as you can see, yeah, it's in the middle, precisely, somewhere here. Not really, right? So it doesn't take into account the width of this entire thing, right? So in terms of y, it also has to do plus the this thing divided by 2, right? So this is also what it has to take into account. And the radius, I think, could have been smaller, definitely, at least 3, right? So, all right, so that's a good slider, I think. It could have been actually put a little bit lower, right, in terms of the padding and stuff like that. So let's actually put like 5 in here. I think that would have been a bit better. So we get some subs, by the way. Let me quickly acknowledge that because I'm not sure if we'll be able to do that. So the real Juf, I hope I pronounced your nickname correctly. Thank you so much for Twitch Prime. Yuri Solovyov, thank you so much for tier 1, and MF Ghosting, thank you so much for Twitch Prime. All right, so this is what we have in here. Cool. I want to be able now to also detect that I clicked on this entire thing. So let's say this is a knob radius, and we also can have something like vector 2 knob position, right? So this is a knob position, and we can put it like that, knob position. There we go. So we have a knob radius and knob position. We need to know the position of the mouse, right? We need to know the position of the mouse and detect that we're inside of the knob. Mouse, cursor. Okay, so you can do get mouse. So there should be a way to get mouse array, whatever the fuck it is. Okay, that's very cool. You can get mouse position. That's very cool as well. Okay, so maybe this is something that we're gonna do. It actually depends, right? So we also want to have a thing scroll dragging, right? Dragging false, right? So can we detect a mouse click, mouse button pressed? Okay, is mouse button pressed once? That's probably what I want. And what kind of buttons can we have in there? Right, so is mouse button down? Check if mouse button is being pressed. So when we actually went sort of down, pressed and released. All right. So we pressed it down. If mouse press down, but what button? So mouse button, I suppose left, right? So we only care about the left one. If the left one is pressed and the mouse position, you get mouse position is inside of this entire thing, right? So vector 2 mouse, right? So we need to find the distance. Distance. I think there was like a math in here. Distance. Yeah, vector distance. This is what I want. I purely guessed it actually. Right, distance between the mouse and knob position. We can even call this mouse position, right, for the consistency. And if this entire thing is basically less or equal than the knob radius, right, knob radius, if it is knob radius, we have to do scroll dragging becomes true, right? Scroll dragging becomes true. Okay, so does that make sense? I think that makes sense. Okay, then if is mouse button released, right, released once on that specific frame, right, released mouse button left, regardless of where we are, scroll dragging is going to be false. And here is an interesting thing, right? If we are in a scroll dragging situation, we need to take the mouse position and we need to translate the mouse position into the scroll value, right? We need to translate it into the scroll value. And this is very interesting thing. So essentially, we're gonna start with just having the x value, right? So we're gonna start with the x value, and this is actually, yeah, we can straight up just do something like x, right? If x is less than the position, basically the beginning of the scroll, right? If it's less, we just assign it back to it. So we clamp this entire stuff. If it is greater than position x plus size x, right, we assign it back to it. So we clamp in that x value between those things, right? So that's what we're essentially doing. We're just clamping it there. Then I'm subtracting a position x from x to make it from 0 to size, and then I want to divide this thing by the width of this entire stuff, and that's the new scroll value in here. Right, so I'm doing a little bit of a like interpolation and stuff like that, but that should work. That basically should give us the scroll that we can use. So we have unused variables somewhere in here. So let me see, why is this thing not? Yeah, this is true. This is not used. What else do we have in here? So yeah, it's not visible because it's array math. So we have to actually include array math in here. All right, so that should be fine. Okay, cool. Can we? Yeah, we can. Why did it work first try? What the fuck? I literally just made immediate UI widget literally for. How did I fucking do that? It's so. Right. People think you need an entire framework to make UI. I literally just made a UI widget out of nothing. Right. Literally, I had only function circle and rectangle. Right. Of course, like I had like a mouse button press and stuff like that. But like I didn't need like an entire UI just to do that. 27 lines of code. What the fuck? I didn't even expect that it will work out. What the fuck? Anyway, I'm sorry. Yeah, why do you need Qt or anything like that? Or how is it supposed to be pronounced? Cute? Right. Or like Slav like or how Slav calls them Qt. As far as I know, all of the Slavs call the cute or Qt as Qt because that's how we pronounce things. Right. At least East Slavs, and I know Poles also call it Qt. I'll know for a fact. All right, so we have this thing, which is kind of cool, and yeah, as a Pole I confirm, yeah. So I used to work in a place where one of my colleagues was from Poland, and that's how I know that Poles also pronounce it as Qt. Yo. Okay, that's a good one. I want to actually train this thing to the point where like both of them resemble something, right? Both of them resemble something. And I would stop somewhere here. Okay, so let's actually make it a little bit bigger. Now the moment of truth. Yo, this is... What the fuck? It is... Look at that, look at this circle. Look at this, it is this motherfucker reusing this circle. What the fuck? I didn't expect this shit, like, holy fuck. This is what it's doing, it's, yeah. Wait the fuck, you can use this for different transition effects in videos and stuff like that. For cool transition effects, like you have two like scenes and you want to transition from one scene to another scene, train a neural network on both of the scenes and transition between them. Look how it's so freaking cool. Ah. Okay, let's actually try to. And by the way, So here we have only one output. We have only one output, which is brightness. What if we add 3 outputs, R, G, and B? So we can have colors. Imagine transitioning not only like shapes, but also colors. Holy shit. This is so freaking cool. I just like, I'm pogged out of my mind like right now. I'm literally pogged out of my mind. This is so freaking cool. Okay, so I think they got to the decent place. Excuse me. This is a decent representation. Yeah. What's interesting is that you can have several images in here. Who said you can have 2? What if we like take n images, we divide 1 by n, and put these images on like equal intervals, and just train this thing to behave like this 3-dimensional, right? So essentially, if you have n images, you have like a 3-dimensional cube, where each slice is the image, and you're trying to approximate that. You're trying to imitate that. So, and that way, by scrolling around, you're going to be scrolling through all of these images, and they're going to be transitioned between each other. Right. What's interesting is that this is a single parameter. What if we have like 2 parameters, or even furthermore? Let me actually see. What if we create some sort of a simplex? And by simplex, I mean like multi-dimensional triangle, right? So as far as I know, like triangle is a 2-dimensional simplex, right? So then you can add 3rd dimension, and you have like a pyramid and stuff like that. What if we have some sort of like a simplex, right? So essentially, we have 3 images, and we basically imagine that they are on a triangle, right? They are on a triangle. And then, instead of a single index, we have 2 indices that essentially describe the coordinates on that simplex, right? And the closer that point is to a particular image, the more it will resemble that image. It's sort of like a barycentric coordinates. And that way you can basically define, I want my final image look more like this one, but a little bit like this one and this one. So we can actually parameterize this entire stuff with a vector, right? So basically you can put these images in a space, in a continuous space, and then your parameter is going to be a point in that continuous space, and the closer that point is to a particular image, the more it will resemble that image. But it also will include elements from other images. Well, wait a freaking second. Is this how like text-to-image models work, essentially? Well, here's the thing. Text is a discrete thing. It's not a continuous thing. But there is such thing as word-to-vec. Right, word-to-vec. It's basically like a family of algorithms that allow you to take words and put them in another continuous space. So is that what like stable diffusion is? It's just like it trained on a bunch of images, and it has these parameters as a vectors, and it just uses word-to-vec to... Is that what it is, really? Like, I don't know. I'm not an AI person. I don't know how these things work, but is that how this thing works? I don't know, like... Yo... Did we just like made a mini stable diffusion or something? I don't know, probably not. These kind of things are probably way more complicated and probably do things completely differently, but it kind of feels like a... I can see like training like a huge model on a lot of images and having like a lot of parameters in here and just like, you know, yeah. It's actually very interesting. This one is cool. Look at this one. And depending on how you train them, they actually transition slightly differently. This is so cool. Oh my god. So, can we make this entire stuff smaller? Right, so I want to make a smaller neural network. Right. I think the smaller neural network is, the cooler transition will become. You know why? Because with a smaller amount of neurons, the neural network is kind of forced to reuse some of the shapes. Right? It's gonna be kind of forced to reuse some of the shape. Okay, so this one is actually rather cool. Yeah. Look at that. It's so awesome. Look at that. It's just like this thing appears and it's just like, oh, the fuck. Alright. So maybe since we have sliders, I can probably make a slider for a rate as well. If you know what I mean? Right, so then at some point, if it starts to spike around like that, I can just like stop it and just like reduce the rate a little bit manually and then continue training. That would be would have been interesting, I think. All right. Would be kind of scary if 0 prime would output 7. Yeah, it would be kind of scary, but I mean, it doesn't have any notion of like numbers. All right. Class Illusion, thank you so much for Twitch Prime, and Distontco, thank you so much for Twitch Prime as well. Okay, so we're streaming for almost 3 hours. All right, so if we didn't have that stupid bug, maybe I could manage to actually do that within 2 hours, but it is what it is. That's software development for you, and it isn't what it isn't. So, yeah. So what if we make it even smaller? Right, I'm kind of curious what's gonna happen. So what if it's gonna be like 4? I think at 7.4, it's not really capable of actually learning both of the images, right? They're going to be unfinished. They're going to be very much unfinished. Yeah, I don't think it will be able to figure it out, but yeah. So it's kind of stuck on this kind of shit. It doesn't have enough power to approximate that. But it's trying. It's going somewhere. All right, so I'm gonna do a committee right now, just for people who want to try that out. So let me go in here. Okay. Interpolate between 2 images, and I'm gonna push that right into the repo. So I guess the next step would be to add images and make things like have more resolution. By the way, with the images with a higher resolution, you don't really have to make each pixel a sample in the training data. You can basically sample things with a certain interval, right? Pixels with a certain interval, or you can sample them randomly, maybe even use like a blue noise, right? So do you guys know what is a blue noise? Right, blue noise. Just a second. So it's essentially when you do blue noise on 2-dimensional surface, you have random points with the regular intervals, right? So they're not particularly random, right? But they're still kind of random, right? So we can basically take big images and train on them, but sample not each pixel, but like blue noise sampling. That would have been also interesting. So that will lose a little bit of information, and that will force the neural network to basically approximate between the samples. Right. So yeah, that's pretty cool, interesting topic. And I wonder how many different, like how many images you can like basically cram into that model. I suppose as many as essentially the architecture of the neural network will allow. used for videos to generate images for slow motion. Yeah, so there's a lot of applications I can see for this entire thing. Right, maybe interpolation between frames. By the way, how does these like you know, things that upscale frame rate to 60 FPS work? Do they work like that? Do they just like interpolate between the frames using neural networks or something like that? But I don't know. Right, all of that is super new for me. But anyway, I guess that's it for today. Thanks everyone who's watching me right now. I really appreciate that. Have a good one, and I see you all on the next recreational programming session. Thanks everyone for watching. Love you all.